Welcome back to Variation in Visualized, our series exploring the features and workflow of CETOL 6 Sigma, the 3D tolerance analysis solution that works directly with your CAD model. Last time we showed you how your team's functional requirements are modelled in CETOL through measurements. Check out last week's video on the EngineSoft UK LinkedIn page if you missed out. Today we'll be taking things one stage further and setting up joints between parts in an assembly. A joint represents the functional relationship between two features on a part, how they fit together. Are they two flat surfaces in contact, a fastener centered inside a hole, or a bearing in an axle? Joints are what allowed CETOL to model these functional relationships and define the physical state of the assembly. Let's see them in practice. And here's our model of a caster wheel. And you can see in the measurement tree up here in the left that I've set up a measurement already. So now I need to start building the tolerance stack up, which contributes to the variation experienced by the surfaces in the model. To do that, I need to tell CETOL how these surfaces and other features in this model can move and vary with respect to each other. These joints should be informed by your product's real-world assembly conditions or bill of process. So for example, in this caster wheel, we know that the assembly process would start by affixing these axle supports here to the top plate using these bolts. So that's where we're going to start with our joints also. So let's go ahead and add in a joint which mates the axle support here to the top plate here. I can go ahead and add in a joint like so, and here you see the feature collector. So I'm going to select the bottom plate of this axle support here like so. Let's call that bottom mating surface. And then we will select the corresponding plane from the top plate. And let's just take a look at the orientation here. So I know that I should call this the right mating surface. And now you can see that CETOL has added in the joint here. But what exactly does that mean? CETOL helps us out a little bit with the joint properties window here. We can see that it's added in this joint automatically as a planar contact, meaning that these two surfaces will always remain fully in contact even if one of them moves or rotates around. Since these parts are being pressed together by these here bolts, that's a good reflection of the assembly constraints in this case, but if these parts were just sitting on top of each other, I may instead want a point contact or some other less restrictive joint, which I could select from this drop-down tree here. So let's go ahead and add that in as a joint. And now you can see that the joint has appeared in the model tree on the left underneath the axle support. And as I'm adding in these joints, I'm fixing how my parts can move, or fixing their degrees of freedom. CETOL keeps track of these degrees of freedom, letting you know which parts are still not fully constrained, and if there are any conflicts between your joints. So if, for example, I highlight this bushing here, these yellow arrows will indicate which directions this part is still free to move in. So I know I still have more work to do to set up my model. And if I was to attempt to do something which would over-constrain the model, so for example if I wanted to add in a joint here between this outer surface of this bushing here and the inner surface of the axle support, like so, then CETOL has recommended a point contact for this, but if I was to instead try to make it a planar contact, then CETOL will helpfully inform me that that joint is now over-constraining the model, and that I need to revise how I'm thinking about the joints in this assembly. And that will do it for this brief demonstration video. I hope I've been able to demonstrate just how intuitive and simple it is to set up joints which accurately represent your assembly constraints within CETOL. Thank you for watching, and look out for the next video in Variation Visualized. Stay tuned for more videos in our Variation Visualized series, or learn more about the concepts behind tolerance analysis in our Tolerancing Tooltips series.